We're going to look at a couple of inverse functions. So let's just kind of sum up again what inverse functions are. So if you have a function f of x, you have another function g of x, which is the inverse of f of x, and that's also denoted by f to the negative 1 of x. So it's not negative 1 as like an exponent, it's just saying the inverse. So sometimes it's easier to just call that inverse a different function like g of x. When you have inverses, the x and the y values are switched, and we want to remember that if you do a composition with a function and its inverse, you will end up getting x. The derivative of the inverse is listed here. So another way that we can kind of look at this, like we were saying in the previous slide, that the inverse can also be called a separate function, like g of x. Personally, I would change it and I would say that g of x is equal to the inverse of f. So that way it doesn't kind of confuse you because you see the f prime for the derivative and you see like the inverse and it kind of looks a little bit confusing. So the inverse, the derivative of the inverse, is equal to 1 over the derivative of the original function evaluated at the inverse function. Okay, so either way is fine to think about it. Again, I just think creating a separate function for the inverse maybe makes it look a little bit easier. Okay, so the derivative of an inverse function is going to be 1 over the derivative of the function evaluated at the inverse. So let's look at this example. So if f of 4 is equal to 5 and f prime of 4 is equal to 2/3, find the derivative of the inverse of f at 5. So I'm going to just rewrite this here and call this g prime of 5. So I'm going to be calling the inverse function g just to kind of make it a little bit easier. So I'm going to get rid of that. So the thing that we want to remember about inverses is that the points switch. So the x's become the y's and the y's become the x's. So in this first piece where I have f of 4 is equal to 5, that point on that function would be 4 comma 5, right? The x is 4, the y is 5. On the inverse, it's going to switch. So I would have the point 5, 4. So if I'm using g as my inverse, I can write the point flipped. So instead of f of 4 equals 5, I can say g, the inverse of f, at 5 is equal to 4. And that's going to help me when I go to find the derivative. So if I want to find g prime of 5, I'm going to say g prime of 5 is equal to 1 over f prime of g of 5. Okay, so I'm doing 1 over the derivative of the original function at the inverse function at 5. So because I switched those points around, the 4, 5 to 5, 4, I can fill in this information. So I'm going to get 1 over f prime of, well, g of 5 is 4. So I now know what f prime of 4 is, that's 2/3. So I'm going to have 1 over 2/3, which is just going to equal 3/2. Okay, so the one thing that we have to just remember is what the derivative of the inverse is. Once we know what that is, we can use the information and kind of plug things in order to find it. So let's look at another example. Let f of x equal 1/2 x cubed plus 3x minus 4, and h be the inverse function of f. So instead of g, they're calling it h, but it's the same idea. It's the inverse of f. Notice that f of negative 2 is equal to negative 14. Find h prime of negative 14. So since we know that h is the inverse function of f, we can take the point that they're giving us, f of negative 2 is equal to negative 14, and we can switch it and say h, the inverse of negative 14, is equal to negative 2. So now when I go to find the derivative, so h prime of negative 14, I have 1 over the derivative of the original function evaluated at the inverse, and it's going to be at that point of negative 14. So I have 1 over f prime. I know h of negative 14 is negative 2. So here, they didn't tell me what the derivative of f is at negative 2. So the previous problem they told me, here they didn't. But I'm given the function in this case. So since I have the function of f, I can easily find f prime of x. Right? The derivative, I'm just going to do the power rule here. So I'm going to get 3/2 x x squared plus 3. So if I want to find the derivative at negative 2, I'm going to plug in negative 2. So I get 3 halves times negative 2 squared plus 3, and that's going to equal 9. So I can go back to my derivative of the inverse, and I know f prime of negative 2 is 9, so I end up with 1 over 9. Okay, so sometimes we'll have to do a little bit extra work to find the derivative if they don't give it to us. Okay, and let's look at one more. So let f be a differentiable function such that f of 3 is 15, f of 6 is 3, f prime of 3 is 8, and f prime of 6 is equal to negative 2. The function g is differentiable, and g of x is equal to the inverse of f for all x. So again, they're just defining the inverse function of f to be g of x. What is the value of g prime of 3? So I need to find g prime of 3. So using my derivative of the inverse, it's going to be 1 over the derivative of the original function evaluated at the inverse at 3. So I need to figure out what g of 3 is. So if we look at the pieces of information that were given, okay, this f of 3 is equal to 15. If I do the inverse, it would be g of 15 equals 3. And that's not what I need. I don't need g of 15. I need g of 3. So now I'm going to look at the next piece. So f of 6 equals 3. So that means g of 3 is equal to 6, right? So g of 3 is equal to 6. So I know g of 3 is 6. So I get 1 over f prime of 6. And f prime of 6, they tell me up here, is equal to negative 2. So I get 1 over negative 2, which is just negative 1/2.